Hello, and welcome to Crash Course Environmental Science. I'm Emily.
And I'm Catherine.
And today we're going to be talking about climate change and ozone depletion.
Get ready, because it's about to get hot in here.
Hi, welcome to Crash Course Environmental Science. I'm Jerry. Before we talk about ozone depletion, we have to talk about what the Earth's climate is like. For the past 1,000 years, Earth's climate has remained fairly constant. We are fortunate enough to live in an interglacial period where temperatures are warm enough to sustain human activity, such as agriculture. However, in the past 250 years, Earth's temperatures have risen rapidly. The lower atmosphere's temperature has increased more than it has in the past. The Intergovernmental Panel on Climate Change says with 90 to 99% accuracy that current increases in temperature are due to human activity. This is due to the increase in greenhouse gases human activity has put into the atmosphere. CO2, methane, nitrous oxide all contribute to the greenhouse effect, which reflects radiation from the sun into the lower atmosphere. The greenhouse effect isn't all bad, though. It allows for Earth to maintain the warm climate that humans need to survive. The radiation from the sun is reflected to the lower atmosphere by these greenhouse gases is one of the key components of the Earth's natural capital. It is when we put too much CO2 into the atmosphere that it becomes a problem. CO2 levels have been increasing by 3.3% a year. We cannot let the atmospheric concentration increase past 450 parts per million. A concentration at or above 450 parts per million would push the Earth to the tipping point. Climate change would become irreversible. CO2 concentrations have to be stabilized to about 350 parts per million so that we do not reach the tipping point. Between 1906 and 2005, the average temperature of the Earth has risen 0.74 degrees Celsius. Glaciers have been melting and weather patterns have been disrupted. Several areas around the globe have experienced extreme droughts, negatively impacting agriculture and the economy. If these severe weather patterns continue, human civilization will be deeply disrupted. Sea levels have also risen by 10 to 20 centimeters, threatening life near coastal areas. Thankfully, we have our oceans to remove about 25 to 30% of the CO2 in the atmosphere. CO2 is buried deep in the ocean as carbonate salts. Phytoplankton in the oceans also remove CO2 from the atmosphere for photosynthesis. But as the oceans are warming, they are losing their ability to absorb the CO2. Phytoplankton populations are plummeting. We have ourselves a deadly positive feedback loop in which the Earth will just keep getting warmer. We know for sure that greenhouse gases contribute to the warmer climate, but there are other aspects of nature that scientists are not sure about yet. Experts are still debating whether or not additional cloud cover in the atmosphere decreases surface warming by reflecting sunlight back to space, or increases surface temperature.
So climate change leads to a warmer atmosphere.
So, what's the big deal?
Well, warmer temperatures.
Summer all year long.
More UV rays reaching the Earth.
More tan time.
But the projected rapid change in the Earth's temperature will increase drought, flooding, shift agricultural land, increase heat waves, and cause premature extinction of so many species.
Oh no! Okay, so best case scenario, summer all year long. But what's the worst case scenario?
Well, the worst case scenario is that human activities, along with natural factors, along with the global climate system, reaches an irreversible tipping point. That is bad.
Irreversible?
Well, irreversible for about tens of thousands of years.
As you can see behind me, the Earth is slowly reaching this browning state as climate change continues. Studies suggest that Earth will increase from 15 to 30% of its land becoming affected by severe drought.
That's the size of Asia.
This means that there's slow tree growth, more CO2, and grass fires, shrinking oceans and lakes. 1 billion people are going to face lack of water and more global warming.
Okay, so climate models suggest that global warming will be most severe in polar regions like Antarctica and the Arctic. The light color of snow in these regions helps cool the planet by reflecting Earth's solar energy. When the ice and snow melts, it increases the dark It increases the dark land and sea that absorbs solar energy. The positive feedback loop will lead to more melting of ice, more global warming, and more climate change. So over the past 30 years, snow cover has decreased by about 10%.
So why should we care?
Well, sea ice plays an important role in Earth's climate. It affects average precipitation in certain areas. For example, losing ice in the Arctic Sea would reduce long-term average rainfall and snowfall, leading to decrease in production and food production and irrigation of water. On the other hand, in some areas, it could increase precipitation and lead to flooding.
So sea levels are rising.
So less beaches?
Actually, yeah. Because of the expansion of water, melting of land ice could eventually lead to an irreversible tipping point of storm surges, coastal erosion, destruction, loss of fisheries, submergence of islands in the Pacific and Indian Ocean and the Caribbean Sea, and flooding of coastal cities, leading to the displacement of millions of people. So the bottom line is, we need to avoid any and all irreversible climate change and ecological tipping points.
The Earth's permafrost is melting.
So?
Well, the amount of carbon in permafrost soils is 50 to 60 times the amount of carbon dioxide released from burning fossil fuels. If permafrost begins melting rapidly, these significant amounts of methane and CO2 will be released into the atmosphere, accelerating global warming and leading to more climate change. 10 to 20% of Arctic permafrost is predicted to melt this century. Climate change is also affecting ocean currents.
Surf's up!
No, not quite. Ocean currents are connected and move like giant conveyor belts. They transfer carbon dioxide and warm and cold water between surfaces and depths. The melting of glaciers and increased rain in the North Atlantic caused by global warming could add enough fresh water to oceans to slow and disrupt the conveyor belt. Alteration of currents could lead to changes in climate around the world.
Global warming is now affecting physical and biological systems. For example, a warmer climate could expand ranges and populations of some species to adapt to warmer climates like weeds and cockroaches. But if Earth's temperature went up by, say, 3 degrees Fahrenheit, 30% of species would totally disappear.
What if it rose to 6 degrees Fahrenheit?
Then 70% would disappear. Imagine all the polar bears and penguins just wiped off the Earth's planet.
Forever. We've talked about drought, melting snow and ice, rising sea levels, and animals dying. But what's more important than all of these things?
Food!
Farming depends on a stable climate. Global warming may cause agricultural productivity to vary according to region. Overall food production could decrease.
So no more Doritos?
Initially, food will be plentiful. But by 2050, 60 million of the world's poorest and most vulnerable people will face starvation and malnutrition.
So we're not going to be healthy then.
Nope. Heat waves alone will cause increased deaths and illness for people who cannot afford air conditioning. Warmer temps will lead to breeding grounds for insects, microbes, toxic molds, fungi, and plants that produce allergenic pollens.
Does this mean itchy eyes, runny noses, and asthma attacks? Better get my inhaler.
A layer of ozone in the lower stratosphere keeps about 95% of the sun's harmful ultraviolet rays from reaching Earth's surface. Global warming is destroying the ozone and leading to ozone thinning.
So why should we worry?
Ozone depletion will allow more ultraviolet rays to reach us and lead to worse sunburns, eye cataracts, skin cancer, immune system suppressions, and that's only in humans. What about the effects of the forests and the animals? So, what can we do to help stop global warming?
Well, we can reduce our CO2 emissions.
Right, like carpooling, walking, biking, using mass transit. Shout out to the CTA.
We can also insulate our homes, use energy-efficient windows, and change our light bulbs.
We can wash our laundry in warm or even cold water and use a low-flow shower head.
Recycle and reduce waste.
And plant trees! Yay!